Welcome to this explainer. Look, if you're a CIO or an enterprise IT executive in the semiconductor space, you already know the stakes. Achieving zero-defect quality, it's not just some nice-to-have goal on a whiteboard. It's literally a strict requirement for survival, especially when we're dealing with sub-nanometer deviations. I mean, when a single scrapped wafer lot can cost you hundreds of thousands of dollars, good enough IT simply doesn't cut it. So today, we are setting the stage for a strategic teardown of how top semiconductor integrated device manufacturers, or IDMs, structure their IT systems to achieve that flawless precision. We're going to build out your target state architecture.
Okay, here is our roadmap for today. First, the monolithic software trap. Second, a federated quality architecture. Third, PLM, the engineering authority. Fourth, SAP, the transactional backbone. Fifth, MES, real-time shop floor execution. And finally, number 6, orchestrating the value chain. Let's get to it.
Section 1. The monolithic software trap. So we have to ask this critical question right out of the gate. Can a monolithic, SAP-only or PLM-only approach truly handle both the commercial granularity of your enterprise and the millisecond-level physics demands of a wafer fab? Well, the short answer is absolutely not. Semiconductor manufacturing is just way too complex. You've got capital-intensive fabrication facilities, highly distributed supply chains. You just can't force the whole shebang into one neat little box.
You know, there's this pervasive monolithic myth out there that one system can seamlessly rule all your enterprise and manufacturing processes. But the semiconductor reality, it's a completely different beast. When you try to force wafer-level genealogy or these insanely complex sub-micron design rules into a commercial ERP system, it's honestly like trying to track the movement of individual atoms using a system built for shipping pallets. It just doesn't work. You inevitably end up with manual handovers, endless data duplication, and really painful workarounds. And what happens? That degrades quality, adds massive costs, and shoots your latency through the roof. It becomes a huge bottleneck that literally traps your factory floor.
Moving on to Section 2, a federated quality architecture. Now, notice the clear delineation in the target state architecture we have mapped out here. For a global semiconductor IDM, this is your foundational blueprint. At the top, PTC Windchill should own engineering and product lifecycle quality. Right in the middle, SAP S/4HANA QM sits there owning enterprise transactional quality. And then critical manufacturing MES or MOM forms the absolute bedrock, owning real-time shop floor quality execution. They are distinct, specialized, but, and this is key, seamlessly integrated to eliminate data silos. To really wrap our heads around this blueprint, we have to frame every single software decision around this core concept of the system of record. Listen, we aren't just shopping around for cool software features here. We are assigning strict operational authority. For any given quality event, there has to be one indisputable system of record that legally and operationally owns that data domain and its surrounding context. No ambiguity allowed.
Which brings us to Section 3, PLM, the engineering authority.
The absolutely crucial point here is that PTC Windchill has to serve as the undisputed engineering quality backbone. Why? Well, because engineering quality must remain seamlessly connected to controlled product definition. Think about a DFMEA, your design failure mode and effects analysis. If this is just sitting in a standalone spreadsheet somewhere, it's virtually useless. It has to be mathematically linked directly to CAD models, electronic component libraries, and specific engineering revisions. Windchill handles this natively. It effectively controls those complex configurations that ERPs simply aren't designed to manage.
Next up, Section 4, SAP, the transactional backbone. So when we step out of the engineering lab and move into the global supply chain, SAP S/4HANA QM takes the wheel. SAP operates on a time frame of hours to weeks, which is perfectly suited to be your enterprise transactional backbone. It completely excels at financial valuation, compliance, and material movement. Make no mistake, SAP is your definitive system of record and should own enterprise transactional quality across procurement, inventory, supplier logistics, customer returns, and regulated quality records.
All right, Section 5, MES, real-time shop floor execution.
When you look at the extreme complexity of a robotic assembly line or a high-speed wafer fab, it becomes instantly clear why the commercial granularity of an ERP system just cannot keep up. In semiconductors, manufacturing quality is entirely dependent on manufacturing context. I mean, the actual meaning of a defect depends on the precise process step, the recipe, the equipment chamber, even the exact wafer position. We are dealing with millisecond-level physics here, and the data volumes are just staggering.
Because of this reality, your manufacturing execution system, specifically robust platforms like Critical Manufacturing MES, absolutely must own this space. This is your operational quality execution backbone. It's capturing low-latency physical data directly from the tools. If a process drifts out of bounds even a tiny bit, the MES instantly calculates real-time control limits and fires off automated tool interlocks to stop bad product right in its tracks. It must own real-time shop floor quality execution, complete wafer and lot genealogy, statistical process control, yield excursions, holds, machine deviations, and test events. This is critical. High-speed data that ERP simply cannot handle.
And finally, Section 6, Orchestrating the Value Chain.
Now, this isn't just theory. It's the industry standard. If we look at empirical benchmarks of leading semiconductor giants like NXP, STMicroelectronics, and onsemi, we see a very clear pattern. They do not rely on a single monolithic platform. Instead, they lean heavily into a federated model. They tightly orchestrate PLM for product definition, MES for manufacturing, and a QMS governance layer across their highly distributed networks.
Take a look at how this aligns into an actionable strategy. Think of this mapping as your ultimate cheat sheet. It proves to the enterprise that distributing these precise capabilities is literally the only logical way forward. DFMEA stays in Windchill. Logistics and commercial lots, those stay in SAP. Inline statistical process control stays in the MES. And those cross-functional quality events, like an 8D customer complaint, are managed by a dedicated enterprise QMS that ties the whole thing together. You are ensuring that each process is managed by a platform that was natively built for it.
To make this work seamlessly, we have to adopt this overarching operational philosophy. Quality events should be detected and contained in the system that controls the affected product or material. Root cause and containment belong at the source. If it's a design flaw, you correct it through an engineering change in Windchill. If it's a supplier logistics issue, you settle it in SAP. And if a wafer fails a parametric test, it gets held instantly in the MES. As you sit down with your teams to design your digital future, I want to leave you with this final, provocative thought to consider. Look critically at your current systems. Are you actually driving towards zero-defect quality, or are you trapping your factory floor in a monolithic bottleneck? My strong recommendation to every CIO listening to this explainer is this: adopt a federated quality architecture. Reject those PLM-only and SAP QM-only illusions. For a global semiconductor IDM, PTC Windchill should own engineering and product lifecycle quality. SAP S/4HANA QM should own enterprise transactional quality across procurement, inventory, supplier logistics, customer returns, and regulated quality records. And your MES or MOM should own real-time shop floor quality execution, genealogy, SPC, yield, holds, deviations, and test events. Embrace this model, unlock the true potential of your manufacturing operations, and hit those zero defects targets. Thanks for joining me on this explainer, and keep innovating out there.